Hello, my name's Bob Willis, here with Winnie TV at SMTconnect. And standards are a fundamental part of the industry. They're a fundamental reference source for training and education. And John, do you want to talk a little bit, first of all introduce yourself, but talk a little bit about what we've got in front of us.
Thanks very much. So yeah, my name's John Vickers. I am a master trainer at Advanced Rework Technology. We are a master IPC training centre, and the IPC over the last few weeks have released 3 new standards. And
we've got 3 of them here. So would you just like to talk through it?
So certainly, yeah. So the one you're holding there, that's the IPC 771121. So that is the rework, modification and repair document. So for companies that have the ability to or the permission to, it's a reference standard for procedural requirements for the rework of assemblies. So whether you need to take components off or put components on, equally it covers conformal coating and covers wire splicing as well.
I think the really nice thing about this particular standard, it is a how to do it book. So ideally, you want a combination of this plus the hands-on training to make sure they're doing it right, but it really is a very good reference source.
It's an amazing document to teach because the content, you're right, it's a procedural document and it really is simple in regards to how it works. It's a document that firstly gives you permission to do so dependent on your class, but equally it covers materials and then the procedure itself. So step-by-step information that if you follow correctly will give you the desired result.
Interesting you mentioned if you're allowed, because sorry, I don't care what industry you're in, you know, if you are able to rework a product, you have the skills to rework a product, there is just, you know, products don't fail because of rework, they fail because of bad implementation of rework, in my opinion.
Yeah, by design. If you're reworking something, it's because it's gone wrong. Ideally, it's in the field and then it has a failure and it comes back to you. So ideally, it's not the fault of the design or the assembly. It's down to the environment in which the part is actually functioning. But equally, it could be down to poor design and that you're rectifying that design to, again, get a functional board at the end of the day.
But do you find the customers misunderstand, possibly as I have, that when we're talking about rework and replacing a component because it's failed, they're mixing up the two things, because what I'm talking about is the reliability of a product which has been reworked. You know, that part of it will not fail.
No. If you follow the document correctly, and again, you've got the skill set, this is important to understand. The 7711 is not a document that teaches you how to rework in a practical sense. The idea of the document is that you've already got an understanding and a background in rework. You can already solder. What the standard gives you is different procedures, different ways, using different tooling that you can technically take a component off and put another component back down on the assembly.
Well, certainly that's something that I think any training department should have as a reference. Next standard, IPC, probably the most well-known and well-quoted document in the universe, IPC 610.
So yeah, the 610 is the acceptability standard. So it's essentially the inspection document. So the premise behind the 610 is that you might not always be the person that technically puts the components on the board. You might have a company that does the assembly for you, the assembly is sent to you, and then maybe you then inspect to make sure that the parts have been put on properly. So the 610 covers both board damage, component damage, and equally wires onto terminals. So it's purely an inspection tool.
Do you find that you get involved possibly in discussions about interpretation? Because I generally find, you know, you work to IPC 610, level 1, 2 or 3, whatever that might be, but then a lot of people inspect higher than. They expect to what they think is right as opposed to working to the standard, because the standard is trying to minimise rework as much as it is pass a good product.
Yeah, I mean, It's always down to design. If someone does their job correctly, designs the assembly properly, and then the parts are soldered on the board correctly, then we shouldn't have any issues. But it's not always as simple as that. So with the 610, normally the issues that we find with inspection is down to the amount of magnification that is allowed.
Yeah.
The 610 is very specific in regards to how much magnification you are allowed. And if you've got a customer that you're doing work for, they state that we need to follow the requirements of the standard. Unfortunately, when you ship the assembly off to them, they sometimes re-inspect and won't necessarily use the same amount of magnification.
Yeah.
So if you're inspecting to 4 times, but your customer is then inspected to 60 times, then there's a chance that they're going to find issues on the assembly that aren't issues at all. It's purely the fact that they're using too much magnification.
Well, I think that both of us would find blemishes at that type of magnification which have no relevance to quality and reliability.
None whatsoever.
So I think, yes, defining the inspection magnification is all important. And the third document and final document?
So yeah, the J standard document. So this is the J standard 001. What I like to refer to is the doing standard. So whereas the 610 is more of an end item inspection document, the J standard really is for the people that are actually doing the work itself. So these are the people that are physically soldering the parts onto the printed circuit board. It covers a lot of process as well, so it's good for process engineers. So making sure you're using the right solders, the right fluxes, that you understand how to clean the board correctly. But from an operator standpoint, it's purely down to making sure that the part is put on the board correctly, orientation, damage, and then obviously most importantly, the solder connection itself.
So obviously new standards. So what kind of is your best-selling non-new standard that people are purchasing now?
Historically, the 610 is probably still the most popular out of any IPC standard to which we work to. I would say closely behind is going to be the J standard. Over the last few years, there seems to be a massive rise in companies that are using the J standard as a means of operator training and again an inspection tool. And then obviously the 7711 comes in third, I would say. We spoke about the permissions. There's a lot of companies out there that can't or are not allowed to physically rework an assembly due to the fact of where the part is designed to function. They would rather not have rework and unfortunately scrap the board and use a fresh board in its place. But again, there are a lot of companies that do have the ability to rework, and it is definitely, from a financial standpoint, beneficial to be able to rework.
Well, when you've added so much value in terms of work, and obviously the board, but the components are more valuable quite often than the board, it just makes sense to be able to rework it if not. But there are certain market sectors, automotive being one, and certain automotive companies just will not allow rework. And it's always been frustrating to me to see a perfectly good product rejected or not allowed to pass through for, totally cosmetic reasons. And it's frustrating because, I and you have spent many hours making products.
Yeah, and you're correct as well. And over the last few years, we've all seen a rise in how much the boards are costing to fabricate. Solder obviously is going up in price, but componentry definitely. And there's a lot of boards that have some very expensive components on that simply aren't being used anymore.
So if I was to ask you, what's missing? What standard should we be looking out for next?
So for us, we got the 620, which is the cable and wire harness document. That was released a few months ago. And I believe the 6012 is just going through new revision as well. So that's the performance standards for printed circuit boards. So 6012 is quite a niche standard, and there's not a lot of manufacturers that appreciate that this standard exists. We've got the 600, which is the inspection tool for bare boards once they've been fabricated. So if you buy bare boards in, you can use the 600 to inspect to make sure that they've been fabricated correctly. But the 6012 gets missed by a lot of manufacturers, and this is when the board is manufactured, testing the board to make sure it can withstand the processes and the working environment in which the board is designed to function. So it's a very clever document, but unfortunately it's not a document that gets taught much. There is a rise, and we do try to educate companies as much as possible that the 6012 exists, and it is getting better, it is getting bigger, but the 600 still seems to be the default when it comes to PCBs.
Yeah, because it's a good picture book, it gives you a good reference.
And it's the same with the 610.
But it could be improved with more illustrations, because a lot of people sometimes miss the text and go to the pretty picture and say, well, it doesn't look like that, or it does look like that. Is it a problem? And I know it's, people complain possibly that there are too many pretty pictures in this. This is why it's so big.
Yeah.
But I think, a picture's worth 1,000 words.
Definitely, and that they are designed to be visual inspection documents. So the illustrations are there to aid in the understanding of the text itself. We do promote always that the text is more important than the pictures. They do override the pictures within the standards. And you are correct, the 600, we could do maybe with some more illustrations. Again, this is an industry issue, and the fact that it is quite difficult sometimes to get pictures of illustrations, because unfortunately a lot of the boards are protected by the rights of the owner of the assembly itself. So it is sometimes quite difficult. But we are always, when new standards get released, we are making inroads into getting much better illustrations within the standards themselves.
Okay. John, once again, thank you very much for bringing us up to date with IPC standards and the more popular standards that are out there. Thank you very much.
Thank you very much.